we need to remember what we learned about a geometric series converging or diverging. And we learned that if the absolute value of r, that common ratio, is less than 1, the series will converge to a1 divided by 1 minus r. That is on your formula sheet at the very bottom. That will be the total sum of all infinite number of terms. And so looking at the series we have for 54, you are going to figure out if this geometric series will converge or diverge. And that's based on the common ratio. So how do you get from 2 to 4/3? What do you multiply 2 by to get to 4/3? 2 times how much equals 4/3? If you can't see it yet, we'll go from 4/3 to 8/9. 4/3 times how much gives you 8/9. And so if you can see it here, we're going to test it out for that first two terms to make sure that common ratio works everywhere. So 4/3 to 8/9. 4 times 2 equals 8, and 3 times 3 equals 9. Therefore, I'm looking at a common ratio equal to 2/3. All right, so let's make sure it works for the first two terms. 2 times, if I try to use 2/3, is that going to give you what you need? And yes, we get 4/3 out of that. So we verified that the common ratio equals 2/3. If you still couldn't see it based on what your numbers look like, what you'd want to do is make your own ratio of the next term divided by the one right before it. So take a term, any old term, and divide it by the term that's right before it. And that'll give you your common ratio. All right, so this would be 4/3 times 1/2, which would be 2/3, okay? Or you could have taken 8/9 divided by the one right before it, so 4/3. So this would be 8/9 times 3/4, and that would again be 2/3. So that is another way to figure out that common ratio if you can't quite see it. All right, now is your geometric series going to converge or diverge? Well, since, this is what you write out for me, since the absolute value of r equals the absolute value of 2/3, and that is less than 1, the series will diverge. Sorry, not diverge, it'll converge. The series will converge. Converge to whatever a1 divided by 1 minus r is equivalent to. a1 equals 2, and 1 minus r is 1 minus 2/3. This is 2 divided by 1/3. This equals 6. And so this says that if you were to write out more terms, if you don't stop where the problem stopped, 2 plus 4/3 plus 8/9 plus the next term would be 16 over 27. The next term would be 32 over 81. The next term would be 64 over 243. And you would keep going. Eventually, way down here, you're going to be getting values, fractions that are close to 0, close to 0, close to 0 each time. And therefore, you're not adding anything additional to that basic sum. That sum stopped at 6. 6 is as high as it's going to get, because after you get to the sum equal to 6, the terms that follow are practically 0, and it's not going to add anything substantial to that sum. How about 60? All right, is this series going to converge or diverge? In order to figure this out, you need to know the common ratio. 9 times how much equals 12? Okay, can't quite see it? Well, let's do it the other way. Let's say 12 divided by 9 equals how much? Because that's going to be the same answer as your common ratio. So we've got 12 over 9, and that's reduced to 4/3, and that's as far as you can go. So the common ratio is 4/3. To go from one term to the next, you're multiplying by 4/3 each time. Is your series going to converge or diverge? Well, now, since the absolute value of r is the absolute value of 4/3, and that's 4/3, which is bigger than 1, the series will diverge. In other words, it'll go towards infinity. The sum keeps growing. It does not ever stop and level out and not get any bigger. It keeps getting bigger. No matter how far down you go down the line, you're going to get terms that are going to keep adding a substantial amount to your overall sum. So it diverges. How about 62? Same directions, given to you in a slightly different format, in a summation format. Let's just go ahead and write out a few of these terms. All right, so the first term is 8 times 1/3 to the 1 minus 1. The second term would be 8 times 1/3 to the 2 minus 1. The next term would be 8 times 1/3 to the 3 minus 1. I think you see what's going on here. 4 minus 1. I think we can stop there. Let's figure out what these are. 8 times 1/3 to the 0. 8 times 1/3 to the 1. 8 times 1/3 squared. Or how about 8 plus 8/3 plus 8 over 9 plus 8 over 27, dot, dot, dot. Okay, so now we have to figure out the common ratio. That's the R value. How do you get from 8 to 8/3? Well, if I multiply 8 times 1/3, I get to 8/3 times 1/3. Here, does it work also? 8/3 times 1/3. Do you get 8/9? Yes, you do. So the common ratio is 1/3. 1/3 is your common ratio. Let's write it like this. R is equal to 1/3. There. And so you're going to say that since my absolute value of R equals 1/3, and that is less than 1, my series, the series, will converge. And if it converges, you have to know to what. So it will converge to the quantity, I'm going to write it in general, A1 over 1 minus R, or specifically A1 in this case is 8. So 8 divided by 1 minus 1/3, or 8 divided by 2/3, or 8 times 3/2, or 12. So the sum will get no larger than 12. It will get to 12, and then the terms after, whatever term that was to get you to 12, the remaining terms are going to be practically zeros and not be adding anything in addition to your sum. That's the end.